I am starting, right? Mohammed, last time we have started. Last time we have started chemical bonding, right?
Yeah.
And now today is lecture number 11, and we are discussing coordination number.
Okay.
So, what is coordination number? Coordination number is the number of cation or anion surrounded to oppositely charged ion, right? For example, if you have sodium, you have sodium ion. So it is surrounded by chlorine. It is surrounded by chlorine. So it forms 6 bond with Cl minus. So coordination number is the number of chlorine atom, number of chlorine atom around the sodium, around the sodium. So coordination number is the number of chlorine atom surrounded to sodium ion. This is called coordination number. So it is the number of anion surrounded to anion. Or you can say that it is the number of cation. It is the number of cation surrounded to anion. For example, this is chlorine. So it is surrounded by 6 sodium atom. 6 sodium atom. 6 sodium atom. 6 sodium atom. This is coordination number. So coordination number is the number of cation. You can see that here we have 1, 2, 3, 4, 5, 6. So coordination number of chlorine in sodium is 6. Similarly, coordination number of sodium in NaCl is 6. So coordination number of chlorine in NaCl is 6. Similarly, coordination number of sodium in NaCl is 6. This is coordination number. Any question for coordination number? Okay, Isa, are you in the class?
Yes, sir, I'm here.
Okay. So this is coordination number. Now you can see in this lattice, this is sodium, and this sodium is surrounded by 6. 1, 2, 3, 4, 5, 6. So this coordination number of this sodium is 6. 1, 2, 3, 4, 5, 6. It is surrounded by 6 chlorine atom. Similarly, chlorine is surrounded by 6 sodium atom. Next is physical properties of ionic compounds. Physical properties of ionic compound. Physical property of ionic compound. First heading is ionic compounds are brittle. Are brittle. Can anyone explain what is the meaning of brittle?
It breaks easily. Like,
Yes. Brittle means break easily. Break easily. Brittle means hard substance but break easily. You can say that breakable. Just apply little force and they break. So question is, why are ionic compounds brittle? Yes, can anyone explain why ionic compounds are brittle?
Sir, due to the bonding between the cation and the anion.
You can say that. Look at the structure of ionic lattice of sodium chloride, right? Here we have negative ion, and here we have sodium ion. This is positive ion. So we have series of positive and negative ions. Series of positive and negative ions. They all are attracted. They all are attracted. This is crystal lattice. This is crystal lattice of sodium chloride. Positive means sodium, negative means chlorine. So here we observe force of attraction. Force of attraction. Force of attraction. When you drag or apply force on it, apply force on it, you can observe the change. So when you drag the layer, this layer move. When you apply force, this layer move. When you drag the layer, this layer move. This layer move. Now this layer move forward. Now force of attraction convert into force of repulsion. Now you can observe we have force of repulsion. So due to repulsion, this layer break. Means when you apply force, or drag the layer, layers slide over each other. Force of attraction convert into force of repulsion. That's why ionic compounds are brittle. Ionic compounds are brittle. Are you getting my point or not? This is your
Yes,
first
sir.
property. Beta, any question?
No.
No.
Alhamdulillah. 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 This is sodium. This is chlorine. Na positive. This is Cl negative. Now next point, next heading. Ionic compounds have high melting and boiling points. Ionic compounds have high melting and boiling points. Do you have any idea why ionic compounds have high melting and boiling point?
Strong intermolecular forces.
Yes, because they have electrostatic force of attraction. So correct answer. So two reasons. Reason number one, ionic compounds or ionic bond. Ionic bond is formed due to complete transfer of electron. Transfer of electron. Complete transfer of electron. Point number two, charges are developed due to opposite charges. Due to opposite charges, plus and minus. Due to opposite charges, electrostatic force of attraction. Electrostatic force of attraction is developed. So they have high melting and boiling point because of strong electrostatic force of attraction. Now question. Before question, write a DI. DI stands for doctor instruction. Boiling point, important point. melting point is directly proportional to charge. Charge of cation and anion. Similarly, boiling point and melting point inversely proportional to size of cation, anion. Size of cation and anion. Now, first question. Compare boiling or melting point of the following. Question number 1, NaCl versus NaBr for 3 marks. Now my question is that which element is cancelled out in these two? Which element is cancelled out? Which
Sodium.
element is common? Sodium. Sodium. So cancel sodium. Now you have Cl minus, Br minus. Now which thing is common? Which thing is cancelled out? Now what is common in these two?
So the negative sign.
Yes, charge. So charge. Charge is cancelled out. Now the only factor is size. Size. So in the periodic table, you have fluorine, chlorine, bromine, iodine. So which one has a smaller size, chlorine or bromine? Down the group, size increases. So which one has a small size? Which one has? Yes, which one has a smaller size? Chlorine.
Chlorine.
So smaller size means a strong electrostatic force of attraction, high melting point. So NaCl, melting point of NaCl is greater, is higher. Are you getting my point or not?
Yes, sir.
Alhamdulillah. So melting point of NaCl is greater than melting point of NaBr. This is point number 1. Point number 2, size of Cl minus is smaller than size of Br minus. Point number next, if smaller size, then distance between sodium and chlorine is smaller than sodium and bromine. Let's suppose this is sodium. This is chlorine. This is sodium. This is bromine. If small size, small distance, big size, So R1 is lesser than R2. So if distance is smaller, then the attraction between sodium and chloride is more than sodium and bromide. Beta, are you getting this point or not?
Yes, sir.
Yes.
So the next point, Alhamdulillah. So the next point is distance between Na positive and Cl negative is smaller than Na positive and Br negative. Hence, NaCl has a strong electrostatic force of attraction than NaBr. So more energy is required. So more energy is required to overcome this attraction. This attraction to melt. All points are from the past paper. So you have to learn all these 4 points. Any question?
No, sir.
Now question number 2. NaCl and MgCl2. NaCl and MgCl2. Now tell me which factor is cancelled out. Which element is cancelled out?
Chlorine.
Green.
Yes, chlorine is cancelled out. You have sodium plus and magnesium plus 2. So now charges are not cancelled out. Now which one has more charge?
Magnesium.
So magnesium has more charge, strong electrostatic force of attraction, high melting point. So first point, melting point of MgCl2 is greater than melting point of NaCl because magnesium has +2 charge while sodium has +1 charge. +1 charge. More charge, more nuclear attraction. More charge, more nuclear attraction. Or you can say that more electrostatic force of attraction. More electrostatic force of attraction. Electrostatic force of attraction. More charge, more electrostatic force of attraction. More charge, more electrostatic force of attraction. Hence, more energy is required. More energy is required to overcome this attraction to melt. Yes, any question?
No, sir.
Okay. Rabia, any question? Huzaifa, any question? Hamza?
No.
No. Now, third property is solubility. Third property is solubility. 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 Ionic compounds are soluble in water. Ionic compounds are mostly soluble in water. Soluble in water. Mostly soluble in water. Because water is polar. Because water is polar. Now consider this sodium ion. When you add water, this is sodium plus. Now this sodium plus is attracted with the negative sign of oxygen. We all know that oxygen has negative charge. Oxygen has negative charge and hydrogen has a small positive charge. Now sodium is surrounded by water molecule. That's why it is called sodium aqueous. This is sodium aqueous. Aqueous means surrounded by water. Water is polar because it has negative and positive charges. So water is polar. Now sodium is soluble. Same case for chlorine. When chlorine is added in water, here you have chloride. Now it is surrounded by hydrogen. Again, it is surrounded by positive hydrogen. Positive hydrogen. That's why it is called chlorine aqueous, chloride aqueous. This attraction is responsible for the solubility. Isa, are you getting my point or not?
Yes, sir.
Yes. This is called solubility. Rania, do you have any question?
No, not so far.
Okay, Alhamdulillah. So another property of ionic compounds are so the net equation would be when NaCl solid is added in water, Na positive aqueous is formed, Cl negative aqueous is formed. Next question is conductivity. Conductivity. So ionic compounds conduct electricity, but in molten and in aqueous form. Molten and in aqueous form. Molten and in aqueous form. Can you tell me why ionic compounds conduct electricity in molten and in aqueous form?
The flow of electrons.
Okay. And what about Isa? What is your opinion?
Sir, I also think that they have free electrons in this state, so that's why.
No, they do not have free electrons. Free electrons are only in metals.
Ion.
Ionic compounds have ion. So ions are free to move. Isa, are you getting my point or not?
Yes.
Ionic compounds have ion. So in molten, ions are free to move. In aqueous, ions are free to move. That's why ionic compounds conduct electricity in molten and in aqueous form. So in molten and aqueous, ions are free to move. So they conduct electricity. So they conduct electricity. Otherwise, lattice does not allow ions to move. For example, this is NaCl solid. Now electricity, no current. Because ionic lattice is stable. When you dissolve sodium chloride in water, lattice break. When you heat, lattice break. Now NaCl solid. Either you heat, or dissolve in water. Or dissolve in water. Or dissolve in water. Or dissolve in water. Lattice break. Lattice break. Now you have free ions. Free ions. Mobile ions. Now they can move towards cathode and anode. Are you getting my point or not? Beta, are you
Yes,
getting
sir.
this point? Alhamdulillah. Discuss conductivity of NaCl in CCl4. CCl4 is non-polar. Yes. Can you discuss the conductivity in non-polar? No, non-polar means there is no charges. Can you discuss conductivity?
Sir, I guess it won't be able to conduct.
Yes, but why?
It can
Because it
dissolve in
was
water.
Okay. So first is no conductivity. No conductivity. Why? Because lattice remain stable. Lattice remain stable. In non-polar. Point number 3, ions are not mobile. These 3 points are very, very important. Number 1, number 2, number 3. Any question?
no, sir.
No.
Okay,
Sir, with the
okay.
solubility,
Yes, can you repeat the question?
I was just asking that when we're talking about the solubility, is just mentioning that water is polar enough of an explanation?
Yes, solubility. In solubility, you have to mention the polarity because water is polar. Polar
Yeah,
means
so that's it.
it has positive and negative charges. So
Yeah.
all ionic compounds dissolve in polar, like H2O, like ethanol, methanol, propanol. but ionic compounds are not soluble in in oil, right? In non-polar, because ionic compounds, you know that ionic compounds have charges. So we need charges to break the lattice. Actually, lattice will break by the polar solvent because they attract sodium toward itself, because polar solvent attract chlorine toward itself. So if you have more attractive ions than sodium, than chlorine, so that's why their attraction reduces. Attraction between sodium and chloride decreases and they are free to move. Are you getting my point?
Yes, I get it.
Okay, okay, Alhamdulillah. Now look at the syllabus again. Yes. First is define electronegativity, explain the factor influence the electronegativity of the elements, state and explain the trend electronegative across the period, and Pauling scale value. We have discussed all. Now ionic bonding. So define ionic bonding as electrostatic force of attraction between oppositely charged ion. We have discussed, describe ionic bonding, including example of sodium chloride, magnesium oxide, and calcium fluoride. We have discussed 3, sodium chloride, calcium oxide, calcium chloride, same thing as magnesium for magnesium chloride. Now, next part of the syllabus. Next part of the syllabus. Chapter number 2. Chemical bonding. We have discussed ionic bonding, metallic bonding, then covalent bonding, dative bonding, then shape of the molecule. Okay. Now again move to AS chemistry. So the next topic is polar and non-polar, because I think you may be confused in polar and non-polar. So let's start polar and non-polar compounds. 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 Always remember those compounds. Those compounds may be polar, which contain phone club. which contain Fawn Club. Which contain fluorine, oxygen, nitrogen, chlorine, bromine. Let's suppose we have a compound AB. We have also discussed electronegativity. Isa, what is electronegativity?
So can you repeat the question?
What is electronegativity?
Or it is the power of an atom to attract a electron towards itself?
Bond pair toward itself.
Yeah.
Can you repeat?
It is the power of an atom to attract a bond pair of electron towards itself.
Yes, this is bond pair, right? So case number 1, if electronegativity of A is equal to electronegativity of B. So can you tell me in which direction lone bond pair moves? If electronegativity of A and B both have same electronegativity, can you tell me the direction of bond pair? Either it is towards A or towards B, or remain at the same position.
Remain at the
Remain at the same position. That's why such compounds are called non-polar. Such compounds are non-polar. Such compounds are non-polar. Example, chlorine. Example, chlorine. For example, chlorine. Now, can you tell me either they are polar or non-polar? Chlorine is polar or non-polar? Cl2. Rabia, chlorine is polar or non-polar? Yes, Rabia, can you repeat? Cl2 is polar and non-polar. Isa?
Sorry, could you repeat that?
Why it is non-polar? Rabia, because they have same electronegativity. Because chlorine has same electronegativity.
Mhm.
Both have same power to attract bond pair. So their attraction is cancelled out. So bond pair remain on the same position. Rabia, are you getting my point or not?
Yeah.
I think you are not sure. Now listen
Could
again.
you explain the text in the green part again?
Now, okay. Now listen. Now look at here. This is chlorine. This is now bond is developed, right? So electronegativity means power to attract this bond pair. Power to attract this bond pair. So chlorine and this chlorine both have same power to attract this bond pair. So Rabia, can you tell me the direction of the bond pair, from which direction it moves? Either from this way or this way, or remain at that position?
Stays at the same position.
At the same position. That's why this compound is non-polar. Now are you
Okay, now
are you,
yeah.
okay? Alhamdulillah. Isa, where are you?
Sir, I'm here.
Okay. Are you getting this point or not?
Yes, sir.
Alhamdulillah. Case number 2. Case number 2. If electronegativity of A is greater than electronegativity of B, so in this case, this bond pair move towards A
Yes.
because power to attract bond pair of A is greater than B. So bond pair move towards A. Now, can you tell me if an atom gain electron, which charge is developed?
Negative.
Negative. So this A gain a small negative charge. This is called delta. This is called delta. Delta indicates it is very, very small charge. Delta indicates very, very small charge. And this one gets a small delta positive charge. Now you can see that here we have two poles, negative and positive poles. POLES poles. That's why this compound is called polar. Are you getting my point or not?
So what did you say
Yes,
about
Yes,
the
sir.
poles?
now listen again. A has more electronegativity. So lone pair attract towards A. A gets lone pair, bond pair. A gets bond pair. So due to transfer of electron towards A get small negative charge. A small charge is indicated by negative delta. Delta means very, very small charge. Now electron moves away from B. That's why B contains positive delta charge. Such compounds are called polar covalent compounds. Any question?
No, sir.
Okay. Now first point, due to high electronegativity, of A, bond pair moves toward A. Point number 2, a small negative charge will appear on A, represented by delta. Delta. Delta negative. Similarly, small positive charge. Similarly, a small positive charge will appear on B. Small positive charge will appear on B, represented by delta positive. Next point, as a result, two poles plus delta and minus delta are formed. That's why it is called dipole, and such compounds are called polar compounds. Polar compounds. Any question?
No, sir.
Okay. Rabia, any question, bete?
No.
Alhamdulillah. Do you know what is movement? Have you studied in physics? Movement or torque?
Yes, sir.
Can you define it? What is movement in physics or torque?
Sir, it is the product of force and distance, and the distance should
Force and
be
distance.
perpendicular. Yeah.
Very good. Perpendicular distance. Similarly, dipole movement, it is the product. It is the product of charge and nuclear distance. Nuclear distance. For example, if you have minus delta and if you have plus delta, so dipole movement is indicated by arrow. This is head. This is tail. For example, if you have HCl, it has positive delta, it has negative delta, and the direction is from positive to negative. This is the movement of, this indicates movement of bond pair. This indicates movement of bond pair. As you can see that movement of bond pair. You can see that bond pair moves here. This is bond pair. Are you getting my point or not?
Yes, sir.
Now, next question is, identify polar and non-polar. Polar and non-polar. Yes. Isa, this compound is polar or non-polar? If you have Fawn Club, then this compound may be polar. Fawn Club is very, very important. Yes. Tell me, this compound is polar or non-polar?
Sir, I think non-polar
Why non-polar?
because it's not in a font club.
Yes, exactly, because there is no Fawn Club. So the answer is Non-polar because there is no phone club, no electronegative element. Now question number 2. Question number 2. Yes. Now polar or non-polar?
It should be
Polar.
polar, right?
Exactly, it is polar. Whenever you have polar, form negative delta, positive delta, and show the direction. It is polar. It is polar. Now question number 3. Question number 3. Yes, polar, non-polar.
Non-polar.
Non-polar. Why non-polar?
Because Cl cancels out Cl.
Exactly, because dipole moment is cancelled out. Because central carbon is in equilibrium. Right hand forces equal to left hand forces. So net charge is 0. Net dipole is 0. Non-polar. Because dipole moment is cancelled out, or you can say that net dipole is 0. Net dipole is 0. Question number 4. Question number 4. Question number 4. Yes. Polar or non-polar? Yes.
Will it be non-polar?
Non-polar. Okay, Isa, what is your opinion?
Sir, I think it will be polar.
Why it is polar?
Because chlorine and chlorine won't cancel out.
Exactly, you are right. Because fluorine has more electronegativity than chlorine. You know that phone club, fluorine, oxygen, nitrogen, chlorine, bromine. So electronegativity of fluorine is greater than chlorine. In phone club, you have first fluorine, then oxygen, then nitrogen, then chlorine. So it is polar because electronegativity of fluorine is greater than electronegativity of chlorine. It is polar. Now question number 5. Question number 5. Yes. Polar, non-polar.
Polar?
polar. Polar. Why polar?
Because two chlorine will cancel out, but there'll still be one left.
Exactly. So this is polar. Due to one carbon chlorine bond. So this dipole cancel out. This dipole is cancelled out. While remaining half. Now question number 6. Hamza. Hamza.
Yes, sir.
Okay. Now question number 6. Now question number 6.
Uh-huh.
Now tell me the polarity of the compound. Polar, non-polar.
Non-polar.
It's
Not
non-polar.
polar.
Non-polar. Why?
2, 2, 2, 2. They all cancel each other out.
Yes, exactly. So net dipole is cancelled out. Non-polar because dipole moment is cancelled out. On net dipole is 0. Now this is the case for the alkane. This is alkane. Now second case is alkene. Whenever you have carbon double bond, the compound is called alkene. Now question number 7. Question number 7. Carbon double bond with hydrogen. Yes. Polar, non-polar.
Sir, non-polar.
Non-polar. Why non-polar?
Because there's no element from the foundation.
Exactly. Correct answer. Non-polar. Non-polar because there is no electronegative element. Non-polar. Now question number 2. Chlorine. Yes, polar, non-polar.
Polar.
Why this is polar?
Because of chlorine.
Yes, because of the polar bond. This compound is polar because you have dipole. This is called dipole. Now case number 3. Yes. Polar, non-polar.
Non-polar.
Why non-polar?
Because the chlorine will cancel out.
Exactly because net dipole moment is cancel out. Always remember on diagonal position dipole is cancel out. On diagonal position on diagonal position dipole is cancelled out. Dipole is cancelled out. Now next is, yes, polar, non-polar.
Sir, polar?
Polar. Because two chlorines are on the right hand side. So this is polar. This is polar. Next is chlorine, chlorine, chlorine. Yes, polar, non-polar.
Polar.
Polar. This dipole is cancelled out, but still you have this dipole. Dipole is cancelled out. Polar due to carbon chlorine bond. Polar due to one carbon chlorine bond. Now last case 12, chlorine, 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 chlorine. Yes, polar, non-polar.
Non-polar.
Why non-polar?
Because they all are cancelling out each other. They're diagonal.
Exactly, net dipole moment is cancelled out. This is negative, this is positive. Cancel out, this is negative, this is positive. Cancel out, this is negative, this is positive. Cancel out, this is negative, this is positive. Cancel out. So net dipole is cancel out. Now third case is carbonyl. Carbonyl means the compound which contain carbon oxygen double bond. Twelve. Yes, polar, non-polar.
Non-polar.
Polar.
Polar.
Oh yes, it's polar
Why polar?
because of oxygen.
Because of the phone club oxygen. Exactly. So here negative delta, positive delta. This is polar. Now, if you have chlorine here, yes, polar or non-polar?
So it will be polar.
Polar. Why polar?
Because oxygen
Because
and chlorine are cancelled.
exactly, because electronegativity of oxygen is greater than electronegativity of chlorine. Now tell me, it's polar or non-polar?
Polar?
No, now this is non-polar. Because electronegativity of oxygen is equal to 2 times electronegativity of chlorine.
Sir, how did you know it was two
So
times?
it's hard to tell since we don't have exact values.
Yes, you all are right, but listen, we have phone club. Now you can see that chlorine and oxygen. So electronegativity of oxygen is 2 times greater than chlorine because you have after 2 element. That's why we can say that electronegativity of oxygen is 2 times electronegativity of chlorine. Isa Rabia, are you getting my point or not?
Yes, sir.
Yes, Rabia.
Yeah.
Okay, Alhamdulillah. So electronegativity of oxygen is twice the electronegativity of chlorine. So these are polar compounds. Now the last question. Yes, polar, non-polar. Yes, polar, non-polar.
Sir, polar?
Exactly, polar. Polar. Now, next question is identify nature of bonding through electronegative values. Through electronegative values. Fluorine 4, chlorine 3, bromine 2.8, sulfur 2.5, carbon 2.5, hydrogen 2.1. So inshallah, this will be done in the next class, right? So do you have any question regarding electronegativity, regarding anything?
No, sir.
No.
Alhamdulillah.
Yes, yes, Hamza.
Yes, sir.
Any question?
I just have a question regarding like how do you identify the polarity? Like, you know how you said non-polar because electronegativity of oxygen is equal to 2 times electronegativity of chlorine, right? How do I
Mhm.
identify like the ratio?
We have to memorize. We have to memorize that because Pauling scale, values of Pauling scale, learning of value of Pauling scale is not in our syllabus, right? So we just imagine that the power of oxygen is double the power of chlorine.
Okay, and what's the ratio between fluorine and chlorine?
So you can see that it's 3 times.
Okay, and then fluorine and bromine would be 4 times.
Yes, you can imagine.
Okay,
It
okay,
is
sir.
it is it is just imagination. It is just visualizing values, right? Not the exact value. We have exact value. You can see it here. But learning of these values are not in our syllabus.
Yeah, okay,
We
I got it, sir.
just use this phone club, right? Chalo, take
I
care.
don't.
Allah Hafiz.
It is Allah Hafiz.
Allah Hafiz.
So I have one thing to ask.
Sorry.
I have one thing to ask. I sent you a picture of a book, and I wanted to know if it's still relevant to this day. So could you like answer that?
Rabia, ask me on my WhatsApp number. Inshallah, I will give you more books. Right? I have a lot of books
Yes,
in my
sure.
folder, so I will check. But the best book is your notes. My notes are very, very important. I know you also you can see that depth of my notes, right? So the notes, my notes are totally from the 970 syllabus, right? No extra thing in it. So it's better first look at my notes, then again on my notes, then again on my notes, and then consult the book.
Oh,
Rabia, are you getting
okay.
my point? So please contact me on my WhatsApp number. I will send you different books, right? And I will also share the PDF of these notes, right?
Yes, I have sent you a message, so kindly respond.
Okay. Allah Hafiz. Take care.
Allah Hafiz.